Okay, so today we're going to talk about two-step conversions. So this is the first time we're really going to see two conversion factors stacked on top of each other in a row. Okay, two-step conversions happen whenever you're given a certain amount of one substance. So you're given either mass, volume, or particles, and you need to find mass, volume, or particles of that same substance. So the fact that it is the same substance is really important right here because that will distinguish it from true stoichiometry, which we'll do next. So if we look back at our map that we've been using, this happens, say for example, if I'm given mass of one substance, and I want to find the volume of that same substance. There's no road that goes directly between mass and volume. So I'm going to have to actually go through the mole. So for two-step conversions, again, we can tell they're two steps because we're going from one of these three things to another of these three things of the same substance. We will have to do two steps because we have to first go through the mole. So your very first conversion will be into moles and then back out. So we can go from any of these three to any of the other three. So mass to mole to particles. We can go particles to mole to volume, volume to mole to mass. Okay. So again, our first step is always converting into moles. There is absolutely no direct route between these without that first step. So I like to think of stacking these conversion factors on top of each other, kind of like Legos or building blocks. So you'll see that our train tracks will have slots for two conversion factors when we do this. Okay, so let's look at example G. Example G says calculate the volume of water vapor found in 1.3 or 12.3 times 10 to the 26 molecules of water. So our given right here is molecules, and our end is going to be volume. So, excuse me. We are starting here at particles. There's no direct route to volume. So we're going to have to move in this direction. So our first conversion factor will be 1 mole over Avogadro's number. And then we can move up into volume, 22.4 liters over 1 mole. So our general path is going to be particles to moles to volume. So just like always, we're going to draw our train tracks. And in the very first spot, I'm going to go ahead and put my given. Then I need my conversion factor for particles to moles. So again, that's this conversion factor right here. 1 mole over Avogadro's number. And then I need my last conversion factor. So I've already gone into moles. Now I need to go up into volume of gas, 22.4 liters over 1 mole. Okay, whenever I plug this into my calculator, remember I'm always going to put parentheses around my scientific notation. 12.3 times 10 to the 26th times 1 times 22.4, and then divide by everything on the bottom. Divided by 6.02 times 10 to the 23rd, again, keep that in parentheses, divided by 1. And when I plug all of that in, and I do magic, through the magic of TV, I plug this into my calculator, and I got 45,767.44 liters. If I were to convert that into scientific notation, that would be 4.58 times 10 to the 4th liters. You do not have to convert to scientific notation, but it's just my preferred way of writing things. Also, really quick before we move on, notice I have molecules here, so I need to cross out molecules here. then I have moles on top. Remember, whatever's on top is what you're left with at the end. So I don't want to be left with moles because I'm going to volume. So moles cancels out there, and I'm left with my liters, which is what I want. So again, please make sure you're noticing this pattern of crossing out the units that we're trying to get rid of, and whatever unit we want to be left with is the last one standing over here on the top right. Okay, let's look at a different example. Example H. It gives me 43.3 grams of nitrogen dioxide and it wants liters. So if I look back at my map, I'm given grams, which is mass, and I want liters, which is volume. So I have to do 1 mole over molar mass, then I'm in moles, and then I can do 22.4 liters over 1 mole, and that will give me liters. So I'm going from grams into moles, and from moles into volume. Now, the conversion factor here from grams to moles, remember, is going to be 1 mole over molar mass. That means I actually do need to calculate the molar mass of nitrogen dioxide. Now, if I look at this, both nitrogen and oxygen are nonmetals, which means this is a covalent compound. Also, I have that prefix, di. If I have a prefix, that tells me I do not have to swap and drop. So this is nitrogen dioxide. So I have 1 nitrogen, 2 oxygens. Nitrogen's atomic mass off of the periodic table is 14.01, and again oxygen is going to be that 15.999 that rounds up to 16. So I get 14.01 plus 32, and that gives me 46.01 grams per mole as that molar mass. So again, train tracks, I'm going to put my 43.3 grams in this very first spot, and then I can stack my conversion factors next to each other. So my first conversion factor, 1 mole over molar mass. Molar mass is over here, 46.01. And then I have my next conversion factor, 22.4 liters over 1 mole. I can quickly double check. I have grams here. I want to cancel out grams. Very good. Moles and moles. And then I'm left with liters, which is what I wanted. I plug this into the calculator, 43.3 times 1 times 22.4 divided by 46.01 divided by 1. There's no scientific notation. I don't necessarily have to put any parentheses here. I plug that straight on in and I get 21.08 liters as my final answer. Okay, now is the time for you guys to pause the video and try on your own. When you're ready, unpause the video and I will unveil the answers to those. Okay, our very first try on your own gives us liters and we're going to molecules. So if we look at our path, we're going from volume down to moles over to particles. So our first conversion factor is 1 mole over 22.4 liters, and our second conversion factor is Avogadro's number over 1 mole. Again, we were given 43.3 liters, so that goes in the very first spot. We go through, we cancel out on the diagonal. This is our final answer. Our second try on your own wants us to end up with mass, that's grams, and we're given molecules. So our first step is to convert out of molecules into moles. So our first conversion factor is 1 mole over molar mass. 1 mole over Avogadro's number, which we see right here. And then from moles, we need to go into mass. So that's molar mass over 1 mole. So we actually need to have the molar mass of water, which is found 18.02, molar mass over 1 mole. cancel on the diagonal, and this is my final answer.